What are fertilizers? Fertilizers, for the growth of the plant, we need three main elements. We need nitrogen, phosphorus, and potassium. We also say NPK. N stands for nitrogen, P stands for phosphorus, and K stands for potassium. So soluble compounds which can provide these nutrients such as nitrogen, phosphorus, and potassium are known as the fertilizer. So to improve the agricultural productivity, we use these fertilizers. What's the purpose of the nitrogen? It's for the better growth of the plant. For phosphorus, it's for root system, and potassium is for fruits and flowers. And these fertilizers should be water soluble. Water soluble means it should dissolve in water, because plants are taking their food in the form of solution, or soluble salt solutions are there. So these fertilizers are all water soluble. From where the plants will get nitrogen means from which type of fertilizers? It can get nitrogen from nitrates and ammonium salt, because nitrate means NO3, so it will provide nitrogen to the plant. Ammonium salt means NH4, that will also provide nitrogen to the plant. Phosphorus from phosphate salt like PO4, and for potassium salt, the plants can get potassium. So for the growth of the plant, we need these three elements: nitrogen, phosphorus, and potassium, also known as NPK. Copy this first part of fertilizers. So nitrogen, phosphorus, and potassium are essential for the growth of a plant, and plants are taking that in a form of a soluble salt solution. We call that as a fertilizers. Then for the fertilizer, for manufacture of fertilizer, ammonia is important. So how we prepare ammonia? So when nitrogen reacted with hydrogen, this will result in a formation of ammonia. This process is known as Haber's process, but the reaction is reversible. This nitrogen and hydrogen can react and form ammonia, and ammonia can decompose to form back this nitrogen and hydrogen. The forward reaction is exothermic. So if the forward reaction is exothermic, means the reactants have high energy and the product is having low energy. So to get more ammonia, what conditions are favorable? It should be, we should decrease the temperature. Yeah, high pressure will be there, and decrease the temperature. Why decrease the temperature? Because the product is having low energy, so we should decrease for better yield, or we should decrease the temperature. And But when we decrease the temperature, we will get more ammonia, but the rate of the reaction will slow down. To overcome this, we should use iron as a catalyst, because decreasing a temperature increase the amount of ammonia but reduce the speed of a reaction. So we use iron as a catalyst for this reaction. And there are 4 moles of reactant and 2 moles of a product. So we increase the pressure so that equilibrium shift towards right hand side. So we'll get more ammonia. So it prefers low temperature and high pressure. Even a low temperature is about 450. What's the reason why 450? Because below this temperature, the reaction, nitrogen is having inert nature. Its reactions are not common at low temperature. That's why the temperature must be high. So Haber process is used to manufacture ammonia. From where we get this nitrogen and hydrogen? Nitrogen we get by fraction distillation of air, and hydrogen is by cracking of the hydrocarbon. Then what we do, the raw materials of Haber process, nitrogen and hydrogen. Nitrogen is obtained from air and hydrogen from natural gas or hydrocarbon or steam. Then we purify the gases and pass over a catalyst iron around 450 degrees centigrade and about 200 atmospheric pressure, which is a very high pressure. So what happened? Nitrogen and hydrogen react to form ammonia. But because the reaction is reversible, some of the ammonia might decompose. As the reaction is reversible, ammonia break down again and form nitrogen hydrogen. So what we do, to remove this ammonia from the mixture, we cool down, so ammonia liquefied and removed, and the remaining nitrogen and hydrogen are recycled. Recycle means again we'll repeat, add them into the same process so they can react again. Is it clear? The manufacture of ammonia by a Haber's process. Any doubt in this? So copy this one. The manufacture of ammonia by Haber's process. Okay, now questions related to this. Air and water. Question number 4. A farmer's soil is very low in both nitrogen and phosphorus. Which fertilizer would improve the quality of this soil and most effectively? What could be the answer? Yes, G is the right answer, because nitrogen and phosphorus, a higher proportion of nitrogen and phosphorus in fertilizer D. And it is low in nitrogen and phosphorus, the soil. That's why fertilizer D is the correct answer. Question 13. What's the answer for question 13? Which statement about the condition used in a Haber process is not correct? High temperature is used because the forward reaction is exothermic. So 13A is the right answer. High pressure is used because there are fewer moles of a gas as a product. So that's true. We use high pressure. Iron is used as a catalyst. That's also true. And unreacted hydrogen and nitrogen recycle. That's also true. So question is which is not correct? So A is not correct. So 13, A is the right answer. Question 15. First question 14. What's the answer for question 14? Air is a mixture of gases. Which gas present in the largest amount? So nitrogen, that's why C is the correct answer. What about question 15? Question 15. Which information about carbon dioxide methane is correct? Yeah, B is the right answer. And methane is 20 times greater greenhouse effect as compared to that of carbon dioxide. Question 17. Which statement about a Haber process is correct? Yes, C is the right answer. The reaction is reversible. It produces less ammonia at high temperature because the forward reaction is exothermic. For exothermic reaction, increase in temperature reduce the amount of product. Shift the equilibrium towards left hand side. Boat made from steel can be protected from rusting by attaching a block of more reactive metal to the hulk of the boat. Which statement is correct? Question 18. Now, the galvanizing refers to coating with a more reactive metal. It's not coated completely. So this is not called galvanizing. C is the correct answer because what happened? Look, Rusting is a redox reaction, means it's a loss or gain of electron. So we have iron or steel is there, and we have more reactive metal, example magnesium. So more reactive metal loses electron, so iron surface will have more electron. So iron is not able to lose its electron easily. Question 19. It is not possible to obtain 100% yield. What's the reason? Because ammonia decompose. Yeah, B is the right answer. High pressure, it's because ammonia is a reversible reaction. So ammonia will decompose and it will form nitrogen and hydrogen back again. Metal X is used to make oil pipelines. X is X crude in air and water. X can be protected from corrosion by attaching a block of element Y. Which statement is correct? Yes, B is the right answer because more reactive metal, it will form positive ion readily. This is not galvanizing. It should be more reactive metal. So B is the right answer. Question 21. Haber process for manufacture of ammonia. Which change caused an increase in yield of ammonia? Yes, the correct answer is C, because the forward reaction is exothermic. So if we decrease the temperature, we'll get higher or greater yield of ammonia. Question 22. Question 22. What occur at stage X and stage Y? Yes, C is the right answer. First we filter it, and then we do chlorination to remove any any bacteria or microbes. Four iron nails had different metal wrap around them, and the nails are placed in an open dish with the water and left for a week. Which iron nail has no protection against the rust? Means which of the iron nail will rust? Look, all of them, if you see, aluminum is more reactive than iron. So aluminum will react. This is called sacrificial protection. So aluminum will react instead of iron. So this will not rust. One which is wrapped with the zinc, zinc is more reactive. So zinc will react. Iron will not react. So this will not rust. Magnesium is more reactive than iron. So magnesium will react and iron will not react. So it won't rust. But the one which is wrapped with the copper, copper is less reactive than iron, so iron will react and it will rust, and copper, there is no change for copper. So B is the right answer. This is called sacrificial protection. Like what you have example, a piece of iron or iron nail. Rusting, for rusting to occur, iron should lose electron. But what happens if this iron surface is wrapped with more reactive metals such as magnesium, aluminum, zinc? So what is the tendency of these metal? If aluminum was there or zinc is there or magnesium, they are more reactive, so they lose electron. So their electron travel to iron surface, because iron surface is having lot of electrons now. So iron find it difficult to lose electron and rust. That's how it protect iron from rusting. Because for rusting to occur, iron must lose its electron. But because the more reactive metal loses electron first, that's why iron is not able to rust. So B, because iron is more reactive than copper, so iron will rust. In the copper, there will be no change. Question 24. So from where we get nitrogen, it's by fraction distillation of air. And from where we get hydrogen is by reaction of methane with steam or cracking of a hydrocarbon or hydrolysis. Question 26. The catalyst for a Haber's process. So iron is used as a catalyst. Nickel is used as a catalyst for hydrogenation of alkene. Platinum was used before, and vanadium pentoxide is used for manufacture of sulfuric acid by contact process. Which process remove carbon dioxide from the atmosphere? 27. Which process removes carbon dioxide from the atmosphere? So photosynthesis, the combustion increases the amount of carbon dioxide in the atmosphere. Decomposition of carbonate also, because it give metal oxide and carbon dioxide. Photosynthesis reduces the amount of carbon dioxide in the atmosphere. Question 28. So which lowering the pressure increases the rate. That's wrong, because if you decrease the pressure, the rate of reaction will also decrease. So A is the answer. Lowering a temperature slow down the rate at which ammonia produced. That's true. Rate or speed of a reaction decreases with temperature, or if you increase the temperature, it will increase. Maintaining a high pressure is very difficult and need expensive equipment. That's true. So it increases the cost. Reaction is reversible, so which can proceed forward and backward both ways. So A is the incorrect answer. Question 29. Which process does not produce carbon dioxide? Yeah, photosynthesis does not produce carbon dioxide. Which statement describes the role of iron in the Haber's process? So iron is used as a catalyst in the Haber's process.